All right, I'm back. So anyway, we're gonna have myself. There we go. Got all three of them. And Matt and Davey, and I don't know if anybody else is presenting anything else. But we're gonna start with Matt because he is the most complicated setup of things, I think. And I suppose, you know, if we're gonna call the ambulance, it should be earlier in the day rather than later. Just seems easier. So let me get my
make sure my gamepad's connected.
Shared. Yep. Do you have any videos or just pictures?
I have YouTube video links in the slideshow, which we can watch some of. I put a number in. You know, we don't have to watch all of them. I just put them in as like if people are interested in watching this, then we can watch it.
I've heard this idea. All right, so I got the screen shared.
Okay, let me.
Good. Before I start. Oh, nothing like a live demo. Come on now. I'm sure this thing's totally safety too, right?
Oh yeah, very safe.
Oh, kitten.
Okay, we're just gonna make sure it works before we get talking. Okay, it works.
Doesn't sound scary at all.
No, it's not. My robot's not nearly as scary as a lot of the ones.
So for those of you on the interwebs, I'll play around to highlight in the video for you so you can see what's going on the ground. So take it away, Mr. Matt.
Oh, okay. Okay. I put together a few slides. They're all pictures. There's no real words on here. This is me. I'm the guy who said I'd come here and talk about combat robots. I'm relatively new to the Madison area. I moved here a year and a month ago. So in the middle of the pandemic when a lot of things weren't happening. I moved here from Chicago. I grew up in Peoria, Illinois. So I'm from the Midwest, but I also did 4 years when I was a kid. I lived out in England and also, well, I went to school at University of Illinois. So again, Midwest, but I also lived in Pittsburgh for 2 years as well. So I thought probably the most appropriate way to, oh, can I start the slideshow here? There we go. Cool. Okay. Was to just kind of go through my journey with robotics because people kind of, I say, hey, yeah, I do combat robotics. Have you heard of the TV show BattleBots? Yeah, I'm on that with some of my buddies, which is a really awesome thing that we're really excited to do. And they go, oh, well, how in the world do you like go from, you know, being a human being to then eventually doing that? So I grew up as a kid. I did FIRST Robotics. That was really the start of my journey in robotics. I did FIRST Lego League. It's a picture of our team on the left. That year it was the very first, or no, that was the second year that they had a world level competition in Europe. They've always first has had a world festival. They call it World Festival. It's a world championship event where different countries get invited and come and compete. Well, that was always in the United States. And Europe had a lot of teams and they wanted to invite teams to Europe. So we actually got to go to the Open European Championships, and that's where we are in that picture right now. It was in Buda, Norway, which is north of the Arctic Circle. Then, that was when I was in middle school, continued to do FIRST Robotics in high school. There's a picture of me my senior year in the drive team. After I graduated, I wanted to keep doing robotics because I was really into that stuff. So when I went to college at University of Illinois, I looked around at the quad day they call it, where all of the different clubs are out in the quad and they're like showcasing their club and trying to recruit new people. And there wasn't a whole lot going on. There were a few clubs, but and I got involved a little bit, but then in the end, I decided I wanted to start a new club for robotics at University of Illinois, and that club's called iRobotics. And as a part of that club, I competed in a competition that was local at University of Illinois that is now called MRDC, that stands for Midwest Robotics Design Competition, but at the time was called JSDC, Jerry Sanders Design Competition. And the team that competition was, I guess, similar to FIRST Robotics, where you have a new objective each year. They design a game that has game elements like balls or hoops, and you have to do things with those to score points during a limited time. And the robots are mostly remote controlled inside of an arena with other opponent remote controlled robots. You can see kind of like a picture of the field. This competition in particular was a 4-robot free-for-all. So different than FIRST Robotics, where you have 2 teams of 3 robots facing each other. This one was everyone for themselves. my big thing, on the right is my senior year. You can kind of see on the bottom right there, the drivetrain that we built. This was like my big, I would call this really my senior design project, which was to build a swerve drive. And those pods all rotate in their sockets and they all rotate independently. So the robot can do some really interesting maneuvers because it's 8 motors. There's 4 motors controlling the wheel pods and 4 motors each steering the wheel pods. And the wheel pods have the drive axis goes through and then has a bevel gear. So essentially you can have unlimited rotation even on the drive motor, as opposed to if the motor were attached to the wheel pod, then you have a wire that can only go around so many times before it tangles. So nowadays you can buy such things from like Andy Mart or Vex or probably like CTR across the road. So there's enough robotics companies now that just like make these primarily for first robotics competition teams, I believe. But I was very proud of it at the time. And that chassis is currently, well, it's currently in my basement, but I planned to buy, I bought all the parts for it from the club. Except we were a relatively new club still, didn't have a ton of sponsorship. So I used my internship money to pay for the robot and took it home with me when I graduated and turned it into a coffee table. So I took all of the manipulator parts off of it that played the robot game, but I kept the bare chassis with the swerve drive and all of that. So it needs some repairs, it needs some dusting, and we got a control board donated to us from National Instruments. And so it was programmed and controlled in LabVIEW. Well, I don't have LabVIEW license anymore. So, and when we have people over for dinner and I want to show off the coffee table that can drive around, I can't drive it anymore. So one of my unlimited list of projects is to put an Arduino or something else on here that I can actually control without having to have a license for LabVIEW. But that robot is still intact, still here. Another thing we did too is competed with iRobotics was Vex U, which is Vex Robotics started up a college level competition. It uses Vex components. You know, they like that because they make a lot of money off of it. Very similar to First, so I also did that. While I've been competing, I've also been giving back and volunteering back primarily in First. And I've been doing this since I graduated. Actually, even when I was still in First, as a high schooler, I was teaching Lego programming classes because that was the thing I was really into when I was in Lego League, is the programming side of things. So I've done refereeing for First Lego League, and that's in the bottom left there. I did that a number of years, and now I'm one of the tournament co-coordinators for the state championship tournaments in Illinois. And I know I live in Wisconsin now, and so it's a little awkward to say that, but I'm continuing to do that because Illinois is not that far away. I did volunteer and help judge at the First Lego League state championship in Wisconsin, which actually was in Madison this year, which was nice. Didn't have to drive super far for that. Besides that, I also do emceeing for First Robotics competition. And I was fortunate enough to actually I was a relief MC. I was not a primary MC, but I was still very humbled and excited to be able to do that at the First Championship in Detroit, the last year that it happened there in 2019 before COVID. That's in the bottom right there. So, okay, so then I did all this stuff in college. I was doing all this in college. Didn't do any combat robotics, you might have noticed. I haven't not been involved at all in combat robotics. Well, I'm a competitive person and this is my hobby and I wanted to keep doing this stuff after college. So some of the other people in iRobotics, that club at University of Illinois, were doing combat robotics. And I kind of talked to them and I went with them during my senior year to one of their competitions. And I was like, oh, what is this? This is cool. This is something I could keep doing and competing in after college. Interestingly, those other types of competitions, like what I call them objective-based competitions, like First Robotics, Vex Robotics, MRDC, those don't really exist for hobbyists nearly as much. There are some things that are kind of like it, like you can have maze followers or maze solver robots, and there's other, events kind of like that, but there's nothing that's, I would say, truly replicates that type of a competition. So I was on the hunt for a new competition, and Comet Robotics was the one. And I did what every new person in Comet Robotics does, which is to come up with some silly idea and go, yes, that'll work great, and then build. So I called this robot the dump truck. And it was more or less supposed to be this really big robot that would scoop up another robot inside of what I call this trapdoor. So there was like a hinge here, and there would be like a cord or a cable that would connect that, and the robot would get stuck in the trapdoor. And then the height of this tower on the back would be designed just perfect so that you could scoop them up, reverse over to the back of the arena, which has a wall that you can dump inside of, and then dump them outside of the arena wall, which would immobilize them. So that was what I built. Oh, actually, maybe I should rewind a little bit first and talk about just the general rules of combat robotics. You build a robot, you have a weight limit for your robot. There are weight classes very similar to other fighting sports like boxing and wrestling. This robot in particular is a 30-pound robot. That robot is a 30-pound robot. The matches are 3 minutes long. It's you against another robot inside a totally enclosed arena. The arenas typically have a wood or a steel floor. The arenas sometimes, it used to be more common, have a retaining wall, which is a lower, maybe a 10 or 12-inch steel wall on the outside of the arena that prevents the robots from driving into the polycarbonate wall, which is what protects the spectators. So that's, and the matches are 3 minutes. If neither robot is KO'd, and a KO is basically, it can be a little hand wavy, but it's more or less defined as your robot cannot move in a meaningful way. So if you're like wiggling a little bit, but you can't actually like move forward, you're just kind of like, wiggling on the spot, maybe you're high centered or something like that, that would be a KO. But if one of your sides of your drivetrain cuts out, and you can kind of use your one side to scoop like this, they usually don't count that. Again, it's kind of subjective. It depends on the event, depends on the referees, what they'll call a knockout, but more or less immobilizing the opponent. If that doesn't happen in 3 minutes, it goes to a judge's decision. There's usually 3 judges, and they usually score on 3 categories: damage, control, and aggression. And those 3 categories, it used to be that it was just 3 points for each category. That was very standard at many competitions. Now it's changed a little bit. On the TV show BattleBots, they do 5 points for damage, 3 for control, 3 for aggression. Some competitions just completely eliminate one of the categories, like control or aggression. They almost never eliminate damage because that's the exciting one. So that's how the competition works. So this robot was meant to scoop and dump a robot outside of the retaining wall that I was mentioning, because then you get a knockout, and it'd be really fast and slick in my mind, and easy, and you'd be able to dominate. Now, I had this big steel wedge on the front to try and deflect all the other spinning weapons, which I have some videos so you can see. Most of the offensive robots use a spinning weapon where they spin up a piece of metal in either this direction or in this direction to a very high speed, and then just drive straight at the opponent and kaboom. So I did this, and the robot got completely destroyed, and my hopes and dreams were crushed. And I was at the cusp of quitting combat robotics due to my rage. But I continued doing it. So I built the robot that eventually evolved into this robot. I went from having something that was like, really big with a lot of weight reduction and is very brittle, to going, you know what, I'm going to build something that's indestructible. So I built this thing that's much smaller and is very, very thick aluminum unibody frame. And that robot on the left is built by one of my friends, who is also now, we are on the BattleBots team together. This robot has a spinning bar here that spins horizontally, very low to the ground. This picture was taken before we fought each other in the finals at a competition, which I won. This picture was taken before the winners finals of a competition that I competed at 3 weeks ago. I'm not going to tell you. Do I not have? Oh, I don't have I do have another picture of that somewhere, don't I? Oh, I didn't put that in. Dang. Okay, I had. So I wanted to put the picture in for this. I must have forgot. This frame, not this. This one. This was before I think me and my teammates got smart enough to order a lot of our parts to be CNC, mostly overseas, because it's a lot more affordable. But I machined that frame by hand in my apartment. So I was living in Pittsburgh at the time, and I was going to a makerspace called Tech Shop, and Tech Shop went out of business, closed. So we no longer had a makerspace that I could use in Pittsburgh. So I bought a Grizzly mill and put it in my apartment, which was on the 5th floor and was fully carpeted. And I used it in my apartment. And fortunately, I came back one day and there was this like orange stuff on my door, and I was like, they found me. And it said that, oh, it was a notice that they had done a routine inspection of my toilet. I was like, oh, didn't say anything about the little workshop I built in my apartment. That's cool. But then the next day, I wake up in the morning and I've got an email from my landlord saying, hey, during routine inspection of your apartment, we noticed that there was a workbench, a drill press, and another piece of machinery in your apartment. You've been getting noise complaints at 2 a.m. You haven't been happening to use your equipment at that time, have you? And I was like, oh, no, of course not. I would never do that. I only use my equipment before 10 p.m. and I use sound dampening mats to help reduce the noise. Harbor Freight, like $4 packs. Anyway, that happened. I built that frame by hand, and I'm very proud of it because it did win me a trophy at a competition. The frames on this robot and other robots are usually, we usually ordered them CNC'd. Now that I have an access to a CNC, maybe I'll do more of that stuff myself. Definitely wanting to play around with it, especially for some of the other parts that are smaller or parts that for some reason get quoted really, really high when I send it to a shop, and I'm like, you know what, I could just do that myself. This sport is definitely a money sink. Okay, so how did this BattleBots team happen? Well, after college, I was doing these competitions. I was competing against other alumni of the same club in the same college, like the guy who built the yellow robot. And we just kind of kept doing that for a few years, but we would go to competitions together and we would help each other out. I mean, we were friends. We knew each other in college and stuff. So you can see there's a picture of us here where we competed at Robo Games, which is in California, and the competition no longer happens, with a 60-pound robot. That robot is named Bigley and was modeled after another 30-pound robot that Ryan, who is this guy, built, called BattleBots. They look very similar. One's just 60 pounds, the other's 30 pounds. And then there's a picture of us in another competition, and there's a picture of, that's the same robot, it's just painted red, Bigley. They're ready to fight a robot called Deep Six, who is also on BattleBots now. Well, that's, his 60-pound version of his robot, but anyway, here's some pictures from us on BattleBots. BattleBots is 250 pounds, so a lot bigger scale than the rest of these. Our robot's name's Deadlift. Our team name is RoboGym. We are theming ourselves after, a bunch of lifter bros, and our robot is also a lifter. Yeah, we have a flamethrower on it. The bottom right is the current, the most recent version of the robot, which is actually currently in my garage, which is our home base now. We're all scattered, so we kind of work remotely. There's a guy in Kansas City, there's a guy in Indy, there's a guy in Chicago who's looking to move to Atlanta, and there's another guy in Pittsburgh. So they all like fly in for 2 weeks and spend 2 weeks here when we're like trying to get the robot together and put it in the crate. Okay, so I have some videos that we can play. I also have my robot to demonstrate, and I can talk more about the robot too. I'm kind of open to how people want, what people want to see. So there's some robots. There's some videos about our. This is a video that we made in collaboration with one of our sponsors, Fictive. That's just kind of like introducing our team and BattleBots and Deadlift. These videos are like 3 minutes for each one. This is a video of our actual fight on BattleBots against a robot named Jackpot. Yes. This one? Okay.
And the red square from Indianapolis, Indiana. For them, it's leg day. For you, it's get down on your knees and beg day. Give it up for Deadlift.
What up, bros? That's right. Oh, they've got the Karate Kid headband working it. And look at this thing. The bot looks much better already.
It does. Very slick. You got that lifter. You also got a flamethrower there. Look at those guns.
Oh, yeah.
I mean the team, not the robot.
Oh, okay, I got it. This bot is looking way better physically.
Yeah, no question about it. I think that confidence is stemming from the new durability that bot has. Again, you know, they really had some serious electrical issues last season. They believe that they have rectified that.
In the blue square, from Las Vegas, Nevada, ready to light you up like a slot machine. Give it up for Jackpot!
A nice ovation for the hometown kids. Jeff Waters and his co-captain Robert Stead. Oh, they have done it up. Look at this bot getting.
I love it. You know, listen, the bot isn't the only thing that's upgraded. Look at the outfits. Very nice.
Oh, Jeff, he's a local plumber who doubles as a pit boss, apparently.
Until you get to the very end.
We made a ton of adjustments. We have forks, we have our weapon swings below the frame, so we hit them as we try to jump over them. And the drive's much better, it's spinning a lot faster. Just all around overhaul.
For us, Jackpot is going to be the bar of how much improvement we did over the offseason. So we ended up having a fight against Jackpot last season in the bounties, and we ended up winning. And so if we can repeat that success, I think is a good testament to the durability of our robot and how well we've improved from last year too.
These two teams have fought before. Jackpot was beaten by Deadlift in the Bounty Hunters season last year when their bot was not able to self-right. Let's see if Jackpot has made adjustments this time around.
It's a TV.
Robots activate. Jackpot. Oh, they look so Viva Las Vegas pretty. Tell us about them.
Well, you see those dual disc vertical spinners there. They have those nice forks. That is new. It's a kind of a different look, and they believe that weapon is going to deliver even more power than last season.
And you know what? Jeff Waters told us he has a little bit of a surprise for Deadlift, our bot whisperer Pete. Do you know what that surprise is?
Yes, the big surprise is during the offseason, Jackpot went on a serious weight loss challenge. And what they did was they reduced weight so that they could bring in the ace in their sleeve, which ends up being Jason Woods with his mini bot, Ace. Don't you remember that from Tracer fame? You gotta know when to hold them and know when to fold them. That's what that mini bot's gonna do for us.
They have another
Yeah, when Pete's working out, he always has Kenny Rogers on his playlist.
Always.
And you're considered knocked out when the majority of those.
Hey, careful, careful.
Exactly.
I don't want you breaking that butt, dude.
So typically you have a small one.
It's Deadlift taking on Jackpot. Who will move to 1-0? We're about to find out. Let the bot battle begin. A little box rush from Deadlift. Tries to get behind Jackpot. Stay away from those spinning blades. Oh, and he just took a shot.
Yeah, Deadlift wasn't able to get underneath Jackpot. Now it does. Almost got a lift there.
Using that flaming lifter, and then goes weapon to weapon. Deadlift trying to take Jackpot for a little spin. In the meantime, the mini bot just running rampant.
Yeah, Jackpot having some drive issues here, Chris.
Yeah, it's got that weapon fully fired up now, but it can't get put in the right direction. Deadlift takes Jackpot into the screws.
Great hit there by Deadlift.
Yeah, Jackpot is having major drive issues, Kenny.
Yeah, they really are. Looks like they're having an issue on that right side of that bot there.
It's actually the mini bot of Jackpot that is the most aggressive. Gets under Deadlift, tries to high center it, but Jackpot cannot work its way over to Deadlift.
Yeah, Jackpot is completely off balance, getting that gyroscopic motion going. But how about that mini bot from Jackpot getting it done?
Jackpot trying to get Deadlift on top of the upper deck, but Deadlift Oh yeah, look at the pretty sparks, and there you go. Jackpot nailing deadlift right in the kisser.
Jackpot coming right back into this fight now.
A deadlift, those dice are bent in front, and takes another shot.
Here they go, Jackpot making a comeback. This is much better. Landed some great shots here. They've had some great damage here on deadlift, which is struggling right now. It seems like they're punch drunk.
Yeah, and in the meantime, Jackpot is kind of stumbling around on each of its hooves. Can't really make any headway toward deadlift. Deadlift is a dead duck if Jackpot can get under it.
Yeah, it looks like they're stuck.
Oh yeah, they're definitely stuck on the kill saws. 50 seconds to go now. Jackpot chopping away like that.
Oh my God, look at those teeth marks on the back of deadlift.
So the kill saws are active and they hit to the underbelly of deadlift. Jackpot trying to get the attack. Oh, look at that. The kill saw does its job.
Yeah, I mean, deadlift is rocked.
Under 30 to go. And Jackpot has got deadlift cornered under the rails. Hard to tell if deadlift is pinned or can't move anymore. And Jackpot just goes in for more in the final few seconds.
Oh man, they are not done. They are chewing away at the backside of deadlift.
This one is going to go the distance. Jackpot struggled the first 60 seconds, but then rolled for the last 2 minutes. And now the decision is in the hands of the judges. All 3 former BattleBots participants, Lisa Winter, Jason Bardis, and Derek Young, scoring on an 11-point system. Up to 5 points can be awarded for damage, 3 for aggression, and 3 for control. Kenny, you had to like the way the deadlift came out of this, taking it right to Jackpot, while Jackpot was struggling with its drive.
Yeah, that's right. They got up to a great start, able to get underneath Jackpot, repeatedly attacking from the back, attacking from the sides. They were getting underneath. They were getting their flamethrower going. They landed some good shots. They had a couple good lifts as well. But then all of a sudden, Jackpot got right back into the game, and I believe it was that mini-bot from Jackpot that really seemed to switch the momentum over to their side.
Yeah, something happened to deadlift's drive midway through this fight, and that allowed Jackpot to really utilize its weapon.
Yeah, you can see it just chewing off pieces off the side and the back of deadlift. Jackpot came back late in this fight. Will it be enough? We'll find out.
The results from the judges are in. The winner by unanimous decision is Jackpot!
So that's video number 1.
A popular decision for the local Jack.
Closes it out. There were no post-match interviews for that one. And then I have 2 videos from fights that I did here. I could also just drive this around first to show it. The promo video? Okay. This was shot here in Madison.
Most robotics competitions and whatnot, it's very task-based. So the robots are asked to do like grab a ball, put it in a hoop, do something to that effect. Whereas combat robotics is you're just going to smash the robot and hope they stop moving so that you can win. So I'm Ryan Shulsky, and I am the captain of RoboGym Robotics. I didn't get into robotics until I was in college. In college, I decided to join a group. We ended up actually making a robot. I didn't know hardly anything about robotics, so I had to lean on some insight from other members.
Hi, I'm Alex Cutie. I'm a mechanical engineer, so I'm kind of the creative genius of the group.
I'm Dan. I am the driver of deadlift, and I am the team angle grinding specialist.
My name's Michael Rouse. I work on the mechanical design, CADing, and some building of the robot.
Hi, my name's Matt Burkle, and I am the one non-mechanical engineer. Those guys are all the mechanical guys, but I'm the guy who does the most machining. So the mechanical wannabes, or maybe I'm the mechanical wannabe. There's a weird dynamic.
Even before deadlift was built, we called ourselves RoboGym Robotics. And a lot of that was because in college we had lifted together.
We competed around the country for the first couple of years, building various sizes of robots.
Combat robotics, there's like
different styles. You have like the really aggressive bots with the hard-hitting weapons.
You got your spinners, control bots, your lifters, your grapplers.
There's a range of all these, types of offensive and defensive strategies.
I think the coolest moment is always when we fire up the flamethrower for the first time. Wow, this thing is going to be great.
So we were building a robot in my garage here, and we needed to get parts shipped to here.
We ended up switching over to fictive for our new configuration here because it was a lot of tolerance issues that we had from previous manufacturers.
The damage is huge after every fight. No matter what it is, things get bent out of shape, things get broken off. And, you don't have an unlimited supply of spares.
That's where the fictive process has helped us the most, is just having that feedback on our parts and being able to make changes on the fly quickly in order to wrap up a design and then get the parts made.
So when we're ready to order, we upload our parts, they give us an automatic quote, and once we're happy with the quantities, we order it, and within a week or two, they're at our doorstep.
You're on a limited timetable, you're on a limited budget. It's expensive to get these parts recut. I mean, they're all custom machined, very, precision parts, so getting them done the right way the first time is absolutely critical.
Competitions are usually won in the pits. When it's boom, 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 you're fighting, twice in a few hours. You don't have much time to fix the robot if anything's damaged. So having spare parts ready and still have the robot ready to go will really win you championships.
I mean, I feel very grateful that I have these friends, every year, because we don't get together only because of robotics.
It's a really fun and fulfilling aspect of my life. We're all like really great friends that, know each other back from college, had been through a lot of both highs and lows. And, being able to do combat robotics and be on BattleBots is just a really unique and rewarding experience to, have a lot of fun with your buddies and build really cool stuff.
It's more than a hobby, right? It's like we all derive satisfaction, happiness from, and we all get to share that with each other.
To get together to, go beat the crap out of someone else's, hundreds of hours of work is even better than that.
Yeah, so that arm was our main arm for deadlift for this season, and we worked with Fictive. They sponsor all of the parts for that arm mechanism, which interesting.
It's Sub-Zero
is controlled with one motor in like a gear system. So when that arm comes down, once it hits a mechanical stop, then the rest of the arm starts to come down over the back, which is not an idea we came up with. There are other robots that have been doing that for a while now. Although the robot that we're building this year is going to have a novel mechanism controlling it, but I can't talk about that yet. Top secret.
How do you balance the weight is a big factor here, right?
Yeah.
So how do you balance that with design? Like I imagine the one motor in that arm would help save weight.
Yep. So I mean, it's really just like making everything as efficient as possible. And having done it for a while, you kind of get a general idea of how much weight you need from certain things. It's also kind of awkward because it is hard to test things too. It's like for a lifting robot, it's actually the easiest to test with because you can safely, especially at 250 pounds, a spinning robot, 250 pounds, if you're like, man, I wonder if we made this axle thick enough on our spinning disc to make sure that it doesn't bend when we hit something. Very difficult to test that. So most of the robots for critical parts critical components like that are very over-engineered. So you make it extra thick, especially for the TV shows. You don't want to mess up on the TV show. With the smaller robots, you can do a little more trial and error by going to more competitions and just like seeing in a sense. Yeah, I mean, I'm not the mechanical guy, so I haven't done all of like the simulation and stuff like that. For our new route that we're building for the next season of BattleBots, we are doing more of like the simulation type stuff. We did do some simulation, for example, on the lifter arm to make sure that it would be fine. But it was way over engineered to like be able to lift it. Anyway, we did also do simulations on the gear teeth. The gears for the arm we designed those. We had them wire EDM. So there is some like things you can do ahead of time.
But with the lifter robot, are you trying to flip it to disable it? Or a lot of robots one flip it, right?
Yes, but you'd be surprised. Yes, most smart robots can. They call it self-riding robots. But yeah, most robots can. Some robots cannot. Some robots cannot just by the very nature of their design. Some robots can drive invertible. Yeah. But like,
is a lift robot trying to throw it into another something on the course instead of help, right?
Yeah. So a lifter style robot will, or a grappler, like one that grab like this. Those robots are playing a control game, so they're trying to push the other robot around, get those judging points, because a good amount of matches for a lifter go to judging. For a KO, it's going to be either you dump them out, or you flip them upside down and not invertible, whatever. Or a lot of times this also works where you take the other robot and you like prop them up against the wall, and they are invertible perhaps, like their wheels stick out above and below their frame. But I call it bookending, when you bookend them like that, their wheels aren't touching anymore. Or like their wheels like might slide like this on the wall a little bit, but it's not going to break them free from the wall. So you can do, if you get someone in a corner and you lift them up like that and kind of lean them against the wall like that, works very well.
So can I just pick you up and hold you?
You can, but only for 15 seconds. And then
That's
they.
not a KO if I'm just holding
No,
you.
not a KO. You can pin a robot for 15 seconds, and then after 15 seconds, you have to back up.
What do you use for a controller and the radio? And is there requirements for like a control switch?
The requirements, there is a requirement that you have to be able to safely go into the arena and disable your robot. So like within like 2 seconds or something. But they're not like making you, like, let's say your robot's fully spun. They don't go, all right, we want to make sure that you demonstrate that your robot's safe to turn off. So we're going to have you put your robot in the arena. We're going to have you spin it up to full speed, and then we're going to send you into the arena to go turn it off. Right? Like if a robot is dangerous, they're going to keep the doors closed until the battery dies. And it is now safe to go in and turn off. But yeah, there are rules that you need to be able to disable your robot. You also have to demonstrate fail safes if the transmitter cuts out, loses signal, or loses battery. Yeah, they have like some precautions.
Taking over
Like
Here's the rules question.
No, okay, that's against the rules too.
No,
You can't interfere with your opponent's control systems. And generally speaking, you are only allowed to use mechanical weapons. You can't use chemical or electrical weapons to disable or damage the opponent's.
So propane's not a chemical weapon?
They don't count propane as a chemical weapon, and similarly, a LiPo is not a chemical weapon, as long as its intended purpose is not to be used as a chemical weapon. So if you put a LiPo on your robot in its little arm and stuck it out there like, haha, they're going to say, okay, that's clearly intended for you to jam into the opponent's spinner, set fire to the battery, and damage the opponent. So you wouldn't, but you're allowed to have a LiPo in the robot because its intended purpose is to power the robot's motor.
So what do you use for brain?
So most robots use RC transmitter receiver setup. Very simple. A lot of the competitors are mostly mechanically oriented. They're not trying to like program their robot. So that's what most people do. They do kind of program it, but mostly on the little screen on the transmitter. Although a lot of those transmitters you can now program actually, they're open source, or they might have some open source compatibility, and you can actually write code for them on your computer.
So you write a routine. So like if you wanted to, you could use channel 8 or whatever on the, you use arbitrary one on the transmitter.
Yeah, you can say this button goes to this, and this button, this joystick goes to that.
Use like Spectrum,
Yeah, Spectra. And there's Futaba as well, and there's other ones, but we have Spectrum. Well, for deadlift, we use Spectrum. Now, what do I use for this? I don't use any of that crap. I use an Xbox controller. Because I have driven robots with Xbox controllers ever since I've been driving robots. And so I refuse to use anything else. And so this robot has a little Arduino on it, and it uses an XP radio. And I have my laptop that has a Python script running on it, and it reads the commands and comes up with a control scheme from this and sends it to that. It's fantastic because I get freedom over what controller I use. So for example, for this robot, I have my thumbsticks, the way I drive is this thumbstick forward backward is drive forward backward. This left right this is for turning. So I have two separate thumbsticks for driving, and then I use the analog triggers to raise and lower the arm. Now on the those boxy controllers, you only have 2 joysticks, and that's all the analog inputs you can provide. That's all they have on them. They don't have analog triggers.
And they give you that controller? Like that's a regulated controller at BattleBot?
You can use any control system you want. They have like certain frequencies that that they have explicitly listed that they'll allow. And then as long as it fail safes, yep, you're fine. And if you're going to do something outside of their clearly specified, like these are the frequencies and whatnot, they will allow it, but you have to like clear it with them first and stuff. They're fairly flexible about that. So yeah, I am looking to change this to maybe use Wi-Fi instead of XP. I'm poking around.
Isn't that first tech users?
Yeah, they use Wi-Fi and FRC as well.
FRC, yeah. And is there a reason they do that versus RC?
I think they just want it to be I don't think. What's that?
You can have a cell phone to do the control.
Yeah, that's what they use for FTC. For FRC, I think it's just like they want it to be very customizable and changeable. Like for first, you want to be able to have like a driver station where you have like a laptop and you have all sorts of feedback, and maybe the camera shows up here, or maybe like other information about the robot shows up on like a driver station, stuff like that. Very difficult to do that with. You can do telemetry with the RC transmitter receivers, but you'd have to like open it up and hack into it. And first, being a large company is not going to open up a Futaba and go, ah, we've hacked it, so that way it'll show up on your laptop. Like, yeah. So.
What are you going to flip over for?
I don't know if we have anything interesting for me to flip over. You might scratch the can. This thing is covered in sharp edges, but I haven't deburred it from the last competition.
I told him when Davey presents, Davey has much sharper things. So however sharp you think.
I have brought weapons with me tonight.
Oh, it's slippy here, very slippy. That's all it does. And so this one, I actually got it geared up enough so that it can, if you put a 30-pound weight in it, hold it up. It's a brushless motor, yeah. When I first designed it, I put a sensor in the gearbox so that I could do a PID controller on it. And I just ended up taking that off because it was like, there was enough variability when it was unloaded versus when the arm was loaded. And it was just like so critical in the moment that like the arm is, when I need the arm to go down and stay down, because this is the defensive stance of the robot. And if the PID controller is doing something weird and the arm's like sitting like this or something, that's really bad. Like if the forks are even this far up off the ground, a spinning weapon's gonna get it. This sport is really a battle of the low ground. Like if you get underneath the opponent, you're gonna have a good time against them.
Did you model this?
SolidWorks.
You did, okay, so it wasn't just start building it.
No, yep. Yeah, actually later I can try to pull up my model. It's on my computer at home and I can try to remote desktop in, but I haven't done it with this computer before.
So how many, you see, 3 motors total?
Yep, there's 3 motors, 3 brushless outrunners. What are the sizes? I know there's a 28 series and a 35 series. I think that might be referring to, in millimeters, referring to the diameter. I don't know if that's like the diameter of exactly what. I don't know if it's actually that diameter of the outside of the rotor. But,
so is the blue on the headlight do the voltage pin when you're moving the motor?
No, so and the one of the LEDs is actually burned out. So it would normally be white when it has comps, red when it has no comps, and blue for going, green for going up, and blue for going down. It's just feedback for me in case, like, for some reason, you know, like trying to see the robot, and I'm like, in the moment, sometimes you small brain it, and you're like, I'm gonna lift them, and instead you're like pushing the forks down, and you're like, oh, okay. And I can do that because I have an Arduino, so I can customize the light. So that is a requirement that you have a light to indicate your power. Oh, yeah. So I decided to do it with an LED strip because I can also get some driver feedback from that.
Is there a reason you box square in the back?
Easier to machine, cheaper, yeah, flat back, yeah. The back does not get hit nearly as often as the front and sides. So the front and sides, I have like those angles to help deflect the spinning weapons. But there are some robots that have, they're like full turtle shell. They have, you know, they have it on the back.
Is this the one that we made some parts for here?
Yeah, so it was this part. And a spare of this part that they didn't have. And another version of this part, which I was working on, as you might have heard, this robot is vulnerable. And there are some robots now, the meta has shifted, and there are some robots that like to hit from the top. And I'm not talking just like a hammer. Like, hammer bots have been around for a while, and they basically don't. Now what teams have devised is what's called a hammer saw, which is, it kind of was an evolution of a saw bot where you have an arm and like an actual metal saw. And now what they do is they put a spinning disc on it, just like what Jackpot had, but obviously not nearly as big because it's on the end of an arm. But if you spin one of those up and then slam it down really hard, it really gouges in. And so this new style of robot has been very competitive. There are more people building them, and they're doing pretty well. So I was trying to design a cover that would cover the sprocket here. So I have another one that needs water that beads that allows me to put some steel plates. So this robot has configurations, primarily the forks cleaned out. So I have some longer, narrower ones that these forks are really thick and beveled, and they're for against horizontal thin robots, and then there's some narrower forks, and I'm looking at more different configurations that will give me like more coverage, like I'll reduce weight from this and put something on the wheels and stuff like that. Because these top hitters, man, they are, I mean, you can see I bought a top hitter. Like there's marks here, here, and here, and here from top hitters.
So you're exactly 30 pounds. I'm guessing you want every brand.
So when usually, yes, you get as close as you can. When I was designing this robot, I wasn't sure. I was trying to play with how small can I make this sprocket and like shaft that here and twist. So I allocated enough weight that I could use the larger sprocket size which I knew would work. And then I was like, okay, let me try smaller. Let me try smaller. And this is the smallest sprocket I could get away with before the shaft on the output of the gearbox starts. So I have a little extra weight to play with. And fortunately, I'm glad I do because, well, now I'm not going to say anything. I think I'm going to spoil things for matches. I'm going to watch a video. I have changes that I want to make, and I'm glad that I have the spare weight to be able to do it with this frame. That's what I'm going to say.
Were you able to figure that out with FBA?
No, I didn't do any of that. No.
Just swap it up.
Nah, I'm a coder, so I like do the model primarily for weight. Sure it fits. And I did do is it FBA where like you see like the color gradients? And you can, like,
Yeah, that's a big
yeah.
rainbow picture.
That thing, yes, I had so underneath this on the bottom, there's a little plate that I call tongue that sticks out, and what that does is prevents the robot from tipping over forward like this when it's trying to scoop an opponent's robot up. And I don't have that plate on here, and I'm not going to say why. I did do FA on that. It's the only thing I've ever done it for, just to make sure that, because it was a relatively thin plate, I wanted to make sure it wouldn't bend and snap when I was trying to scoop.
So
I also have magnet pockets in here. So for competition with steel floors, I don't need to use that tongue. I can put magnets in here, and it gives me enough suction to the ground to prevent the robot from tipping over forward when it scoops.
Is it like a electrolyte?
Nope, just a permanent magnet.
And that doesn't, that's
No,
Because
it's not that one.
You're not touching, you're just.
Yeah, it's there's an area. Yeah.
So FBA, if anybody doesn't know, is finite element analysis. It's taking a 3D model and giving parameters for loads and fixtures, and then asking the computer to calculate whether a material of uniform behavior is going to break or not. It's like there's forks that were bent and then welded and then ground, and whatever. You can't FBA that. That's garbage. But it can if you have like a piece of steel at known hardness and known behavior. The computer can very accurately tell you whether it's going to fail or not. So that's what it does. So the output is a fancy rainbow color picture. You look for the red spots, and then you assume either it's an error in the mesh model in the computer. You can remesh it, try to fix that, or it actually is going to break it. You kind of, you know, FBA is its own art. You want to play the video? Or?
Yeah, let's do it. Let's watch one of these fights. We can watch me fight a horizontal hitter or a vertical hitter.
When do you win?
I can't say.
You look good, I guess.
I think, man, they're both pretty good matches. Ooh. We'll do this one. No, you guys haven't seen a horizontal hitter. We'll do this one. So we watched that fight with Jackpot. That was a vertical hitter.
The box is locked. Looks like we are getting ready to go here in this fight. Red square, lockout. Are you ready?
Lockout is that once it's written over.
Red square, ready.
Ready to go. Blue square, beam. Are you ready?
Blue square, ready.
All right, let's put 3 minutes on the clock, please.
3, 2, 1.
30-pound combat sport action here. We have Beam getting off a little bit of a slower start here, but it looks like they're starting with the weapon upside down versus right side up. Interesting design choice, but I think they want to go after the weapon arm up top. And it's a better angle to hit. And so far, those hits are delivering. Big hits being delivered from Beam. Lockout taking it like a champ. However,
so you'll notice this arena does not have a return.
if you're going to go for some defense, you know, you got to take the hits. And right now, Lockout's taking the hits, trying to get underneath, shoving Beam into the wall.
So that's a situation you want to be in. You want to get him
another
in the corner.
Big hit from Beam.
Two minutes remaining.
Beam now getting up the speed there. Monstrous hit being delivered. The Lockout still taking the hits and keeping on coming.
There's a guy in the corner running this one. Or they might have
another just nasty hit. The Lockout still just playing the offensive game of coming at Beam, saying, all right, hit me again. Come on, is that all you got?
Oh, we can't see.
There we go. Lockout getting a lift underneath there. Getting Beam tipped over.
It's not going.
Can he get Beam upright into a position where he can't get up from? Remains to be seen. But Lockout's a few seconds here to do any lifting he needs to do before he must free up from Beam.
Because
there we are. He
yeah,
gets back out.
Very
Back
low
in.
forward, very high speed. So if you're close to them, they can't spin.
1 minute remaining.
1 minute remaining in this fight. And the hits just keep on coming, and Lockout just taking them, flexing on the hits as it were. Oh, now he gets Beam up in the corner. Not quite. Can't get him to do the thing exactly yet.
But he kind of hit the polygon and fell back.
Just coming down in about 30 seconds.
Inwards a little bit, so there's kind of a Beam and
Beam once again taking some chunks out of the armor. Lockout looks like they lose the side of drive, but still very much in this fight. About 20 seconds left to go.
So if he's going to spin it up,
Beam is taking his time, looking for the right opportunity to hit. And he does so. Now he's stuck on the lifter and freed again. 10 seconds left. 5, 4, 3, 2, 1. That's your match. This is going to go to the judges.
Yeah, the wheels got back right at the end.
Now, it was interesting before I mentioned this fight, we were talking about brushless motors a minute ago. Beam here by the door there, and that blue spinning blade actually uses a brushed motor still on the inside for its weapon. Think about that. That brushed motor is still delivering a lot of hits, although the motors that they use are becoming harder and harder to find now, as supply has run out for some time.
When it gets too hot. So that's why I'm glad I have extra weight. I can put in slightly bigger ESCs and bigger heat sinks and handle that.
Judge's decision is in for your winner, Beam.
So Beam ended up going undefeated and winning this tournament.
Lockout just.
This was the only match that was not a knockout for him. So I was at least proud of that one.
It's interesting that they gave it to him because you were after him constantly.
Yeah, I was 2 times. I was very close to a knockout as well. But this was the first match that I had this season. I hadn't really had time to have as much driver practice and stuff. So definitely missed a couple spots there where I could have. But you can kind of get the picture of how a lifter can get a knockout and how a lifter can win. Is in those situations like that, if you do get them propped up, then you get it.
So the smaller robots just you, not with your buddies?
Yeah, so the smaller robots, we all went together. And the roundhouse you see in the top left is up next. That's another one of the guys. So we went to this competition. We brought 3 of our 30-pound robots, and 4 of us were able to go. So one of the guys was just like pit crew helping out. So we've all built our own 30-pound robots, and those are our individual robots, but we all help each other, and we all paint them and stuff so they all match. It's still a relevant theme. Yep. Okay.
How much does one cost? Like dollars?
I think you could build a robot like this without, you're not gonna have a ton of spare parts, and the prices are gonna be totally different now, but probably for like, I'm gonna say $2 to $2.5 grand, probably. But you do more of it yourself. Yeah. You could do more of it yourself. You could also not have a unibody frame. You could like just do flat plates that are like welded together or something from send to send. Be much cheaper than doing something that's got CNC'd parts. This is somewhere in between. There's some robots that are like ridiculously over CNC'd and just like you hate to watch them go into the arena. It's like you want to go everyone's around there taking pictures of the robot when it's clean before it's going in for its first fight. And then Yep. Oh, I guess one more interesting rule too. Some competitions allow this, some don't. You can have a non-wheeled robot. And if you do, you get more weight allowed. So if you have a shuffler, which would be a robot that uses like cams or something instead of round wheels, then you get a 50% additional weight. So in this weight class, you'd be 45 pounds. And if you are a totally walker, you get double the weight. So you'd be a 60-pound walker. That's like an electromagnet robot would be considered a walker. It has to, and that's kind of a fuzzy ground because the normal definition of a walker is that the piece that goes and contacts the ground has to be able to touch the ground and then move and then lift off the ground. But they count the electromagnet like activating the FA as lifting that foot up and on and off the ground.
Another video on play?
We can watch it. It's another fight. I don't know. I'm kind of like monopolized the entire meeting.
So, in the orange gear, you can't back out, and you're gonna black out when you get into an all-out bout with Lockout.
This one has
and in the blue gear, are you tired of knives that are just about as sharp as a doorstop? Well, this bot slices and dices, and it makes everything nice. Introducing the Blades of Glory!
It's
Lockout, are you ready?
Yeah.
Blades of Glory, are you ready? All right, give me a countdown. 3, 2, 1, battle! Oh, Lockout going for an early slam. Blades of Glory getting in the blades, spinning up. Oh, Robot's getting into a bit of a shoving match. Blades of Glory can't make contact. Then he makes contact. Lockout pushes him on the wall.
So I'm choosing not to.
Lockout's got him pinned. Okay. Blades of Glory coming back down. Trying to go away at that front wedge. It's not going to have any teeth left. That's a dentist bill and a half. Lockout's got him picked up. Blades of Glory comes back down. Puts all the scratches on Lockout. Oh. Grinding away at that front plate.
It's hard to represent.
Oh, chunks are flying. Shredding off that front plate from Lockout. But Lockout managing to keep most of the impact just to its front. Oh, it picks up. Lockout picks him up. But Blades of Glory drops back down. Picked up again. Oh, fancy turn from Blades of Glory. Getting pushed around now by Lockout. Into the wall. Oh, almost up and over. Blades of Glory sees its chance. Heads it from the side. Going around the side. Lockout's got it again.
What's that?
Blades of Glory escapes. Goes through the side. Misses. Lockout pushes it against the wall.
Oh, yes, I would have to. This robot, it like
So
the arm
lives.
goes such that it can get itself back.
We're halfway into this match, and the fighting is going on intensely. Lockout seems to be keeping it distant. Oh, the sparks are flying! Oh! But Lockout keeps it pinned. Oh, big hits. Oh, Blades of Glory. Stops hitting. Smoke! We got smoke out of Blades of Glory. Lockout trying to push it out of the arena. Oh, pushes it up on the wall.
So,
can they do anything? Is that a countdown?
So this match I drove very conservatively because I knew I walked around the pits and I looked at this other guy's robot. This robot looks good, and I saw his batteries were quite small, and I was like, I don't know if he can go for 3 minutes. So I think looking back on this match, there were times where I probably should have tried to speak more often, but in my mind I was just like, run it to 3 minutes. He's not going to make it to 3 minutes. Run it to 3 minutes. And his robot actually did shut down here right behind. So.
He had the spinner running it.
He had the spinner. No, I ended up fighting him a second time, and he was smart enough to not run the spinner the whole time, and he did make it to 3 minutes that time. So, but yeah, okay, that's all I got. Oh man.
So people might not know, Madison actually has a deep history in combat robotics. There's at least 8 to 10 robots that came from the general area from a handful of builders. But one of the more fun things is one of the popular judges on BattleBots right now, Lisa Winter, actually grew up right here in Madison, lived in Monona.
Oh wow, really? I did not know that. Yeah, I know Lisa. She's one of the judges.
Yeah, exactly. I've known her, well, I think since she was born, but her first robot she made when she was 14.
Oh, wow. Okay. That's cool. I did not know that. I'll have to see if I can catch her attention at BattleBots and say, hey.
Madison, Wisconsin.
From Madison. Yep. Deadlift's built in Madison. Our team page says Indianapolis because that's where Ryan, who's our team captain on BattleBots. Although I would say generally we're a pretty decentralized team, but
yeah, and if you mention Wisconsin, people are like, "Oh, are you with the Waiachi folks?"
Yeah. Our robot ended up going on the same truck that went and picked them up immediately after us. So I was messaging Jake. I'm like, "Oh, the truck's on the way to you guys next."
Nice.
Questions, anybody? Dennis, it wasn't a question.
Guess when the first robotic competition was?
Like period?
The first one, I think it was 91?
94.
94. Okay.
We were there.
Anybody else? not nearly as
I don't know. I didn't see a battery lockup.
Yeah, go for it.
Okay.
Thank you for not taking out the cat's bed either. Easily disappointed.
I thought you weren't gonna flip it. Saw that thing running around. Did you really just like relax next to it? You didn't know the BattleBot at all?
Not exactly. She's affected at all.
How does she know it's not gonna?
Blind ignorance.
Yeah. She sees no lights. She's figured she got the game figured out.
Very sophisticated.
All right, give me a second.
Dave, do you know how to do this remote presentation kind of thing? I mean, I know you probably struggle with this.
Yeah, I mean, every now and again I try it.
It's like 90%.
Yeah. All right, so I don't have a fancy. I never have a fancy presentation. Oh yeah, you got to share. Yeah. So this story started many moons ago when I learned how to 3D print, and I figured out that Chris has Ninja Flex. So if you ever want a project to do with Ninja Flex, print these things because they freak people out when you throw them at them, and they're fun. So you know, I've always been a Batman fan. I've always done various different projects. So fast forward to about a year ago, and I'm getting a job in CNC, and my brother, who is a self-proclaimed Luddite, was like, "What in the crap are you going to do with a CNC machine?" And I was trying to get him, you know, him bought into my whole plan. I was like, "Well, I can make batarangs." He was like, instantly, like, "Do that. Take the job. Get in there. Let's see it happen." So anyway, fast forward some more time, and I got some time to play on a machine. And so I started making them, and this is more of an evolution of my kind of learning on how to do like palletized, you know, multiple parts at a time. Because when you're doing CNC, if you're doing a one-off part for a bracket or whatever, you can do it however you want. In production or semi-production, you need to start like skidding out multiple pieces. And so here I kind of started with, so on the left side, I've got a set of jaws in a vise, and I'm just holding, you know, a piece of material. And this is all just nonsense material that I found and begged, stolen, borrowed. Some of it came from here, some of it came from wherever. And so there's like holes all over it. And I'm just kind of getting the feel for what's going on. And so, you know, the first operation, oh, I forgot to do, I had some pieces that I forgot to bring. And I guess underneath the blue tape, you can see that the first operation on any one of them is to do the chamfer on one side. And so the big trick when cutting a batarang is that you're cutting material around the whole thing. And so you don't have like a nice little block that you're holding onto, and then you like mill out a pocket and drill some holes and do some other stuff. And so, you know, and I've got a couple of these, you can kind of pass them around or whatever. They're crazy sharp, so be careful.
They're like crazy plates in cars.
Yeah, it's mainly just this tip here. It's not this edge. But anyway, so I was just kind of experimenting around, and I got a couple of these cut. And so ultimately, my burn rate was way too high. And so in this one here, I'll use the pointer so the people on the interwebs can see it as well. In here, you can see the top chamfer cut. So I cut down with the 1/4" end mill to clear it out, and then I come back and do the chamfer cut. And then I'm using super glue to hold it down for the next round. And so then you can cut it all around. And so that's what the blue tape and super glue is all about. And then this is just a hunk of aluminum that I had that I milled flat and put a shoulder into. And so basically you can barely see it underneath this hole. But what I would do is drill a locate hole in the first operation and then probe off of that once I flip it. And I think the next picture, oh, it doesn't have it. But anyway, so I learned just a crap load about work holding and milling, and don't use flood coolant when you're doing the super glue technique, because I kept delaminating the blue tape and just tossing my parts into the wall. So that's why like half of these are done, half of them are not, half of them they failed somewhere through. And I'm not really going to talk about how much money I put into end mills for this project. But I learned a lot, so you know it's worth something, right?
When the part goes flying, the end mill's engaged, the end mill goes flying too.
Yeah. There's a few times where I was really glad that I had an enclosure around the mill that kept things contained. And so anyway, so eventually the natural progression is after I had like an awkward pile of these,
I decided to kind of ramp up production because what else are you gonna do? And so that's when I started getting into like laying out, and I wanted to do a sheet. This is the full working envelope of a 770, which is I have at my disposal. And so I kind of went with, how many can I stuff in here? And if you look closely, there's 2 different sizes, 4 big ones and 4 small ones, just to kind of stuff in there. And so I kind of just went down that road and laid them all out into a kit and then kind of laid. And so the fun part about this is I use Fusion 360 for a lot of CAD CAM work. Fusion 360 has no idea how to deal with a chamfer, as far as I can tell. You can chamfer a hole, but if you want to say like follow this chamfer around this thing and I've got a chamfer bit, no fucking idea what to do with it. Chamfer, like I've talked to everybody and their brother at work. It's like, oh no, you got to do this and this and that, and never, I can never get anybody to tell me like step by step how to get it to work. And so I actually did something crazy in this day and age, which is I went to conversational on the mill and just did it manually because I knew that I needed a so-and-so deep a cut and so-and-so offset a cut. And so what I did is I fudged all my tools, and I've got a 3/8 inch end mill, and told the controller that it's a 64 thousandths of a diameter end mill and put it on the outside of this line. And that gets me my tip 32 thousandths off the center line. And then I know that because of the geometry of the tip, that's going to give me a nice flat clean cut on a 1/4 inch plate of aluminum. And so there's some fudging involved and a lot of kind of not necessarily manual, but I kind of had to just tell it really super specific what I wanted to do instead of letting Fusion figure it out, which sometimes Fusion does really well, sometimes it sucks at it. And so basically in CAD, all I had to do was lay out this is all the chamfer cuts, and then this will be all the head cuts, the flat cuts at the top. And then, so then this is how you end up with all these batterings. And then in here, you can see how I laid it out, and kind of just stepped it through. And here you can see the different cuts. It's kind of hard to tell, but there's like for the 1/4 inch end mill, I was able to do just, 2 depths of cut, just kind of plow through it. But then on the chamfer, I kind of walked it in real slow, partly because I still barely have any idea what I'm doing, and partly because I was going for a nice, real smooth surface finish. I probably could have taken some deeper cuts and then just did a ball haircut at the end. I'm kind of figuring out as I go. And then the head cutout, to get that inside corner radius, I had to use an 1/8 inch end mill, which is why, there's such a small step down on those, just to kind of walk it in. So at the beginning, my success rate was about 4%, which was appalling, but gave me something to do. Now I'm up to into the plate by plate. I usually get 7 or 8 out of these of the 8. So that's pretty cool. And I've really kind of dialed in the process just kind of for fun. And so this, I guess I just realized I didn't give you a picture of the fixture. But so underneath here is a fixture plate, which has a bunch of tapped holes and a center locate hole. And so the first thing I do is kind of locate off that center hole in the fixture when I first come on. And then I actually kind of have to, and this comes later. So this is the first kind of iteration that I did. And you can see like these screws here, I figured out too late in the game that they were right smack in the way. And so I kind of had to change some stuff around as I went, but this gives you an idea. And so this is another thing that I learned on was this one was, so this is all blue taped up, and I specifically did it so that the tape doesn't split on the batarang because the glue will squidge in there and then you have a dorked up surface finish. And so I kind of go through extra pains to do that. And so from one at a time, I could do one side, glue it, do the other side in the course of about 45 minutes to get one. And now I've got it where I can do a plate of them in about 1 hour and 10 minutes and get 8 of them. And that involves like, most of that time is either the machine running on its own or messing with the tape and the super glue. And then in here, I was trying to do locate holes. So I have these little 1/4 inch diameter pins that are, locate pins. And then I had, I actually made the holes in the plate 2 thou oversized so that it would kind of snug on there. I don't know if I was getting super glue in there or like my bit was wearing out. I was getting a little bit of wear. And anyway, it kept getting tighter and tighter, and it just became a pain in the ass to work with. That's when I figured out to do the square holes in the middle. And so I have in the fixture plate now, there's 3 pins, and you can't really see them here, but there's 3 pins. So there's 2 on the x-axis and 1 on the y-axis. So when I put a sheet down, I kind of slide it into the corner, and then that's my locate. And so then once I probe this center hole on the first op and the second op, I could just kind of do this indefinitely. I don't really get that much like continuous time to do this. So pretty much I'm probing every one, but the theory is if I was doing these all day, I could just kind of set it up and go.
How do you get those sheets cut to the perfect size?
That's the end of the, I'm going to get to that. That's the end. That's the good part, the tips and tricks at the end. And so, but yeah, so I've got the sheets cut down to size, and then I kind of have to do a few operations. So op one would be just to get the thing ready, to poke all the holes and to cut my locate squares. And then if anybody in chat has a question they want to see, that you can just holler at me. I don't really care. And then I'll check the chat at the end or in a few minutes. Okay.
Currently, no questions in chat.
Okay.
We're just yammering amongst ourselves.
Okay. So this is after I do the first op to get the material ready, and now I'm ready to actually start cutting. And then this is what you see here, right? So this is operation one. From here, this is where I'll tape it all, tape the fixture plate, and then flip it and glue it. And then I'm ready to do op two. And so I purposely keep all the head cuts at the end, partially in hopes of getting a good surface finish, which I haven't gotten yet. If you look, I think I'm going too deep on my cuts or too fast. I got to play with that recipe a little bit. And then, yeah, so then op two, it kind of just does the rest of it. And there's a few things. Another one that I learned here is this center. So these little these screws, if you look real close, the diameter of this screw head and the diameter of this piece is just slightly different. And so every screw I have now, because I've done this a handful of times, has a side shaved off of it. And so my next move will be to pocket these out like I do on the center hole. I think the center hole, yeah. So now, because I actually started tossing them because I've got too much interference here with, cutting and not enough glue and work holding in the middle, and I can't get screws here because of the, an eighth, you don't want an 1/8 inch bit that's this long, so you're down to the collet and all this. So this is the only bit of cam that I did in Fusion, was just to pocket out this hole before I come in, and I slightly undersize it. So when I come in to cut this out, there's no material in here to toss, because I was losing the center ones that would get tossed on that end cut. And then I want to do that again for, I guess I don't know how much the people at home can see. I'm going to do that again for these here, just to get rid of them so that I don't have to hold those down.
The pieces remaining become a problem, because he's cutting them and there's still material there that breaks up with cost free. So that's why he has to have all these screws all over the place, is to hold the scrap in place, so the scrap doesn't screw everything out with the real pieces.
And since I'm making throwable pointy things, obviously the next move is to turn these center pieces into their own stars. I just haven't done that yet. I apologize. I will. That's like next move, because it lends well to that. It just happened to be the void. I didn't even notice it until I cut this one, and I was like, oh, that looks like a throwing star. So that'll be my next move.
Can you explain again the square in the center? Like, why couldn't you just indicate that with a sheet round hole and flip it over?
You mean this square here?
Yeah, you can talk about.
Well, let me see if I can get a better picture.
It's just the pins are interfering because the glue is getting stuck in the elephant.
Yeah.
An elephant works great until you start putting glue on it, then it kills all the elephant.
Or, yeah, my tool wore down a little bit. So my next hole was a little bit, just a few fuzzes smaller. And so it was sticky. And so when I was pulling them up, I was like wallering out the holes in the fixture plate, because I was sticking and resticking the dowel pins. And so now I've got 3 pins here, one that rubs this side, and then 2 that hit this side. And so then when I put it down, I can push it away into the right, and then it locates into those pins. And because I'm using the full working envelope of the machine and the full throw of the bed, I could also do it on the outside of the material, but then I'd need a machined edge on that material. This way I can control the flats that I'm kind of interacting with. And it's just a little bit of extra cutting. I mean, looking at it now, I could probably make those holes different and smaller and whatever. If I was doing, if I was ramping up for a production of hundreds of thousands, then these holes would be like, a lot tighter to the pins. And this is just a kind of a repeat of the pictures. Oh yeah, you've seen all this. So yeah, and this is what it looks like after I kind of remove all the junk. So needless to say, I've got batarangs for days. I'm going to put them out. You guys are welcome to take one. I really don't care. I'm going to continue to make more until I figure this process out because it's fun. I'm not going to do that mainly because I don't feel like it. My little brother sold one for $12 and he promised me 4, and I still haven't seen that yet. So
After he's done getting the product liability insurance.
So one of the cool parts about, obviously I didn't do any of this at the sector. I have the CNC capabilities at home, which is pretty awesome. But one of the benefits of like my membership here and what I do here is I was here for a work day when we were working on fireproofing some beams or whatever, and I happened to kick into a sheet of 1/4 inch. It's 2.262 inches thick for whatever reason. I think it's painted because it's got a texture to it. I don't think it's anodized. But anyway, there's a sheet of this. It was about 30 by 40 inches over by the ladder, and I kind of kicked into it, and I was like, well, hey, I just worked all day. What is this little piece of material doing? And so I gave Chris some money for it, and I took it home. And then this is what I'm kind of using now. Everything in the past, and if you look at these, there's like oddball holes and stuff from like, because there was a fixture plate of something that I pulled off of something, in the scrapping and whatever. So it's been kind of fun for that reason. Here's a very tiny video that I'm really depressed at how small it is in this size. So I'm not even going to push play. I don't even know if I can push play. The very first one I got done and successfully cut after 8 failures. It happened to be my buddy's 40th birthday. I gave him one for his birthday. He totally didn't get the how much money and time I had put into it, and was kind of like, oh, need a batarang. And so he actually recorded a video, but I guess it got stomped on enough times through text messages. Let's see if it works. Oh,
Batarang. Sweet.
Yeah, so they work. I thought it was gonna be like this small, this size, so I was kind of glad that got bigger.
Batarang.
Yeah, and so this is a hobby in the sense of I'm making these and kind of learning about production, and then also when me and my friends get together, we can whip them across the garage and stick them into things, which is also fun. So this is back to Chris's point. This is the bonus tips and tricks. I have this whatever chop saw that is an abrasive wheel saw that I put a carbide tooth blade into, and I was like, it's amazing that I didn't lose a finger, and please never tell my wife I did this. But I was like hacking this material into pieces on this drop saw and holding it in really precarious ways and removing parts of the saw to make sure it was just terrible. And that's when Chris enlightened me to the fact that aluminum can be cut on a carbide blade in a wood saw if you wax it. And so to get this massive sheet cut up, I just took my regular old circle saw from whatever cutting plywood, and I took paraffin wax and I kind of tapped the trigger, stuffed the paraffin wax into it, get that blade nice and gooey, and then then from there it cuts like butter. It was amazing. So if you ever have to cut sheet aluminum,
This was after about 2 days of convincing Davey that I wasn't trying to sell.
well, because he said, we've got the Milwaukee saw, and I almost came to borrow the battery one, or brought the sheet over here, put it on the plasma, the water jet, all this other stuff. So that was pretty cool. So I can cut one of these and not have to worry about it. That's as far as I've gotten.
You can feel it, the saw stop. It's like running into a wall on the wax runs out. The wax runs the aluminum binding on the teeth. So as soon as your blade loads with aluminum, it just stops making tips.
And you have to clean all the aluminum.
Then you get to knock aluminum off. So the way I learned this was in school. We had a 1-inch thick plate of aluminum that we needed to cut up. We didn't have we had a big bandsaw and stuff. No good way to do it. And the shop boss was like, "Oh, grab the circular saw." Me and another guy were both sophomore student interns at the shop. He's like, "Oh, grab the circular saw and just chop that aluminum off." We were like, "What?" We both knew enough to know it doesn't seem good. He's like, "Yeah, just put wax on there and it's fine." So we went at it. Sure enough, it worked great. And that was 1-inch thick stock, and you had to give it a little bit of rest for the saw to cool down. Otherwise, it works awesome. That was the same suggestion.
It's got to be a carbide tooth though. It can't be like an old steel tooth or whatever. I'm not sure what would happen at that point in time, but so that's.
How far did you cut in it?
Oh, you got 6 inches to a foot. I think the blade is all. Yeah, press blade if I go. Yeah. What the wax is doing is melting as it's needed. Yeah. As the plate heats up and the blade heats up, it melts and then it gets loose. It loses the whole thing. Yeah, it was. It took us a couple hours. We had like a huge plate section down.
In my box of tricks here, if you guys are at all curious to see all my failures and some successes, this is my favorite design, but it doesn't stick because it's not pointy, so it didn't make the cut. But this is one of my favorite ones. So you can't have this one if you're digging through the box. This is the one that me and my brother were hanging out, and I was like making the batterings one at a time. And so I had to reprobe each one and mess with each one. And we were just like drinking beers in the garage and messing around. Well, it wasn't until this one came out of the machine that I was like, oh, I should not be operating heavy equipment right now. And if you look real closely, I have, to this day, I have no idea how I did this or what I did or what changed, or it's like completely like this side looks great. This side, everything's wrong. Not really sure how that worked. Anyway, that's about all I got. I left about 15 at home. I've given about 20 away, probably in the 50s or 60s. I did about 30 of them one at a time. And then now I've done like 3 or 4 sheets of 8. So, and I'm going to move up into, I want to do a couple of steel ones, and then I'll probably like, call that my capstone and move on to something else. But yeah.
Buy some titanium board budget test.
Oh yeah, yeah.
Do you have any other questions for Davey? So Davey has this planted in his garage. It's not his apartment. Sorry, Matt. He's got it out the garage. They're debating what to call multiple batteries.
Oh, okay. Yeah.
Very
Yeah.
I monitor the chat. So. Oh my god. That cat's awake.
Yeah.
All right. So I've got just some pictures, and then I think that's it for tonight. Let's see. So I'll show you the screen here real quick. I'm just basically giving a quick overview on kind of where we're at doing building construction. So for those of you who haven't been here before, we bought this building about 4 years ago and we've been renovating it very slowly since then. And our latest step is we got the permits approved for the 2nd floor. And so we are working on building the stairs and protecting some of the beams and columns that go below the caretaker's quarters, like an apartment on the 2nd floor on that side of the building. So this is a picture of Mark and Davey. Nice work. You guys made the slideshow. But this is the first layer of drywall to go up. These are these clips that go on, and then it holds the drywall a certain distance off the beam, which has been underwriters laboratory tested to withstand fire for an hour. And so that's what these clips are doing, is holding the drywall at a certain configuration so that the beam doesn't get too hot. And as we know, jet fuel, won't melt steel, but it will sometimes. So it turns out if you heat this thing long enough, even though this giant beam will soften, and then when it softens, the concrete will collapse. And because the caretaker's quarters is residential and this is business, you have to separate those uses. And the prescription on how much to separate those uses depends on the uses. So in this case, we need a 1 hour fire separation. The floor provides 1 hour fire separation, so it's 8 inches thick of concrete, another 2 inches on top. So if we had a fire down here, it wouldn't get through the concrete floor anyways. But if the steel collapses, then it got through the concrete anyway. So that's why you have to protect the structure. So you have a 1 hour fire separation for structure and for the floor itself, providing the separation. So I know much more than I ever wanted to know about building construction. So this is in the wood shop. So we had to take down all the wood off the shelves. And then you can see that the column is also cladded. So this has 2 layers of 1/2 inch drywall, no spacers, no standoffs required. And then it does have this requirement of using galvanized sheet steel or stainless steel as a cladder. And then it has to stop 1.5 inches short of any constraint, 1/8 inch per foot standoff, so that if this got really hot, the steel won't expand and then buckle itself. So you have to give it expansion space for if there's a fire, the steel can't basically pop itself off like a tin can from expansion, which is kind of interesting, but it really makes sense that the steel would stretch over the length of this column. And if it runs into something, then it pops itself free, and then the drywall is exposed and can burn the drywall off. Interestingly, when they do UL testing, the end test is a fire hose spray. So it has to both withstand the heat itself, but also the spray of a fire hose. So that's why when you see fiberglass, it has wire wound in it, or like mesh through it. And that wire allows the glass to shatter. but it doesn't allow the fire hose to penetrate through the glass because there's enough of it held in place by that basket of all the wires. So that's why you see fire rated glass looking like that.
What's the fire hose? I don't understand.
It's Underwriters Laboratory certifies a design. So in this case, these clips are certified by a company called Grabber. Grabber makes this product called a CB60 clip, and they have to pass a test where they literally put this assembly into an oven, and then they spray with the fire hose.
And the fire, but I guess the question is, the fire hose, are we talking about thermal shock or the pressure of the hose?
All of the above. Yep. So they have a hose at a prescriptive distance with a certain volume flow of water going through a certain nozzle. And the assembly goes into an oven, sits and bakes for a certain amount of time. Then they pull open the oven door and they spray with the fire hose. And then they have some criteria. I don't know what it is offhand, but it can't either have failed or have fallen apart a certain amount.
Well, what's the advantage? I mean, wouldn't the fire situation when you want to get that water ready like possible, therefore it's flat?
If they break the protection off, I think it's because if the fire continues. So if you spray down all the columns and now the fire rages again, and then the whole building falls down anyways. So if a fire department shows up within 5 minutes, right, hoses down a bunch of stuff, knocks all the drywall off, and then there's a rager that's still burning, and then they back off, now the whole building collapses because wasn't protected adequately. I think that's what it is, but that's totally coming out of my ass. So somebody have to actually go read about it. So the next step, the next bit of fun that we're working on now is building the stairs. So these are diamond plate tread plates. So Brian was kind enough to volunteer the shop that he works at, which is a big fabrication facility that manufactures can conveying solutions. So they move all of the cans, the aluminum cans that you buy that are full of soda. They depalletize, palletize them, and stack them for all these big food and beverage companies. And so they have big machines like this thing. This is, I think, a 15 or 20 foot shear. And so we were loading the diamond plate into the shear and then shearing it into the 44-inch by, I forget what the length is for each one of the steel treads. I'm going to skip a step, which is bending, because I wasn't there when we bent them. And then separately, Advanced Concrete Solutions in town was kind enough to order us some steel on their account, which saves us about $2,000 because they buy a ton of steel and we buy no steel. And so we get totally murdered on pricing. And so these are the stringers, the side plates for the stairs. And then this is the stair landing, which was built out of scrap from that assembly manufacturing company. They had some decking that they didn't need. And so we laid out all the steps and realized that they were slightly overbent. So they were less than 90 and we needed them to be slightly greater than 90. So next time we go and bend more, we'll bend them slightly over 90 instead of slightly under 90. So we manually unbent them with a crescent wrench and a pipe wrench, which was lots of fun. We're probably gonna use the brake to unbend the next stack of 16 of them to bring them back. So then this was this weekend, there's a pipe wrench on there. You can see the huge pipe wrench to unbend them. Turns out the brake does a whole hell of a lot of work to bend them in the first place. And so unbending them is not great. So then we were using some ratchet straps and a bunch of lasers and a bunch of eyeballing to get the steps square and straight and in the right spots. I think Sean said we were off by about 1/4 of an inch over the run, which is totally in spec for wood, but for metal, we really shoot for thousands. So we're just a little disappointed. This is the underside of the stairs. And then we got all the way to the floor and didn't screw up. The increments were even, so that was good. Measuring to the like 50 thousandths of an inch because we needed to not be off by too much by the time we got to the end. So we've got a steel staircase. I need to finish welding it. You can only weld a couple inches at a time. If I weld more than that, what'll happen is I will pringle the whole step. So if I put in too much heat stress into this, the whole step will pop and then I'll be sad. And so I've got to weld a little bit and then walk my way up and down these steps a bunch of times to get them fully welded along the edges, but not pringle them into a chip, which will be good. That's it. So this is at the opposite end of the building, and this staircase is going up this way and then up this way at the kind of head of the car bay. And the other staircase will get built where this wood insert is up in the Spancrete deck. So when we originally put the Spancrete and steel in place, we had to know where the stairs were going to end up and have all these things designed way ahead of time before we did anything at all with anything. And then now we're working back and actually placing the components and verifying clearances and things like that. This has clearance to like 1/8 of an inch of where it needs to be on this door. The door was kind of put in at a random spot and the staircase spot was dropped randomly. And so it all works out good. Worst case, we would have had to turn the staircase left instead of right, which would have made things a mess. So it worked out good. Or move the door. Sean was ready to tear the door out and move it. So anyway, that's the construction update. So we work on this periodically, I haven't been emailing out this stuff just because it's fairly specific work, and so like the couple of us that are working on it are all used to beating each other over the head trying to do pain in the ass anal work. And we're all very tired by the time we got done building the very small set of stairs. Then we slept on it, but now we've got a way better idea how we're going to build. This next run of stairs starts at about 4 feet off the ground and goes up to 13 feet off the ground. We're building them in place just because it's easier than trying to build the stairs on the ground and erect them. It ends up weighing, I think the whole staircase weighs 2,200 pounds when it's done. So it's not a trivial amount of weight. Like each step is pretty heavy, but when you put a whole bunch of steps together, it turns into a whole lot of weight. So yeah, so the staircase is about $3,000 for the staircase. So you can either have a 30-pound combat robot or a 2,200-pound staircase, your choice. You know, the only thing to keep in mind is that there's no labor going into no labor costs associated with bending the treads, shearing the treads, or making the stringers. It's just raw material. So that's the $3,000 is literally just the steel stock going into it. And we bought the stock a long time ago before steel was crazy priced. It's kind of been sitting at Brian's factory, and the guys there have been nice enough to kind of ignore that it's been there. But the bean counters went through and audited the building, and we're like, why are there a bunch of steel plates sitting here? So we got some awkward looks for that, but it worked out good. So now we've got all of it sheared, and then the next step is to bend up the ones for that side and get those down here as well and go from there. So our next fun outside, and my email said if anyone has any ideas on concrete forms and wants to get out a shovel, our next step is to actually dig the foundation and footing for the elevator. So the elevator will be outside, attached to the side of the building, kind of right down by where the 3D printers are. So we'll be cutting a hole through the wall, and then, but before we do that, we need to put the foundation in. So we've sent off our check. We wrote a $35,000 check for paying for half of the elevator. So thanks everyone for paying your membership dues. If you ever want to know where it goes to buying stupid things like elevators, but they're code required, so we got to do that regardless. Anyway, we sent that off, and so one of the people from the elevator company that's up in Appleton is supposed to come down to meet on site, take a look, make sure they're not doing anything totally ridiculous, and then verify that we have an idea of how we're going to pour the footing and foundation wall and go from there. So that is the next bit of fun. Yeah.
Is the elevator on that wall or that wall?
It's that wall, north side. So it'll pop out kind of where the gravel parking spots are. Where we stop pouring concrete going this way is right near where the elevator is going to be. And we stopped pouring concrete in fall. We could have got another run in, but I didn't want to be digging into the concrete that we just poured, because then we're going to have to pour it again. We're really good at doing things multiple times though, so it wouldn't be unexpected, but we'll be doing that.
Why
Yes,
do you have
Mr.
to
Mark?
weld all the way down the lines and staircase? Is it for ceiling?
Because we don't want junk to fall through our stairs. So one thing would be is if you're going up and down the stairs with wet feet, you're going to get water through the staircase, and then it's going to get on the drywall on the bottom. The stairs has to have 2 layers of 5/8 drywall on the bottom to provide fire protection. So the stair enclosure will be 1 hour fire rated as well. And so it's called a protected means of egress. So that stair will be enclosed. This stair will be fully open, and we'll share airspace with down here. You're allowed 1 connected floor in a building. So if you're ever in a big fancy building, they'll have like 1 big open entry staircase, all the cool stuff, and then every other floor after that will be isolated. Or they've done crazy special things for fire code, or they've gotten an exception. So one of the big exceptions that I'm aware of in town is the Engineering Centers building. If you go in that building, it's this huge atrium. It's like 5 stories tall, gigantic, got the really cool terrazzo floor, and all open staircases all going up through all these levels. But the atrium area is its own airlock, and all of the rest of the rooms are through a 1 hour fire rated wall on the other side of the airlock. So that atrium is its big own space. And then there's massive fans. They're like, they got to be like 8-foot diameter, and they're like every 50 feet down the whole side of the building, and it evacuates all the air out of that whole building with louvers. And so it kicks open. If there's a fire alarm, or a fire test, they will kick on all of those things. It's like a jet engine running out of the building to suck all the smoke out, specifically to allow them to have that huge open towering atrium space. It's otherwise prohibitively expensive normally to build, but university cost is no object, no unapplicable. So in our case, cost is very much an object. so we get 2 floors, but you can do that every other 2 floors. So essentially you can join 2 floors together throughout a building to make that entry kind of space like that. So there's all sorts of annoying fire things that are all over the place. Same with, you occasionally see really short ceiling walls. Those are smoke blocks. So you'll have a staircase that's open, and they'll have this little stub wall at the top of the stairs that at that floor, that's to block smoke from going up into the next floor for long enough.
How do they do the low cut?
How do they do what?
How do they do the low cut? The giant
It's all the same. It's playing with all the fire codes. It's like how you can get a LEED certified building. It's all glass. Like LEED is like the super environmental green, certification, and glass is terrible, the worst thing in the universe. It's because they can put in a high efficiency furnace. It doesn't mean they're not throwing just tons and tons of energy at the building. It just means that it's all high efficiency. So you're very efficiently using all that gas that you're burning. So their building code is very frustrating in that regard because you can spend a lot of money working a way around everything, or you can follow the rules and then you end up with like a very boring thing. So it's interesting the way that it splits. Any other questions about that?
Well, the stairs back here or here, are they gonna have a structure or are they just attached to the concrete in the floor?
So this staircase that we're building now, the stringer is the structure.
Right.
And then it's the landing is anchored to the floor, and then the top of the stringer is anchored to the steel beam.
So there won't be legs or anything like that.
There won't be
You
legs or
can hang
anything.
the
No.
weight.
Yep. So we can suspend the weight, and it's the same thing over here. It's going to go down, and then there'll be a deck across the top of the bathroom, and then it'll extend out with a landing to allow us a door right there, and then it'll come the rest of the way down. And that I think there might be 2 legs, but I don't think so. I'm not sure. I got to look at the plans and see what it says. But again, all this stuff was designed like a long time ago. So now we're updating the models to reflect reality when we make final measurements and figure all that out. So I guess by way of also saying that, down in the car bay right now, there is tape on the floor, and I have wood on top of the tape to prevent you from stepping on the tape because it's all of our precisely marked out treads. So I guess if you shift the tape, you can totally screw the whole staircase up if you want to have some fun. But ideally, don't step on the tape because that'll help us do our jobs easier. All right, so I'm going to kill off our stream here. Thanks everybody for coming. We will catch you another day, perhaps.